April 30, 1942, Heston Aerodrome, England. Test pilot Ronald Harker climbs into the cockpit of a sleek silver fighter that's about to change the course of World War II. The aircraft beneath him is a North American P-51 Mustang, powered by an Allison V-1710 engine. It's fast, it's beautiful, and according to every expert who's flown it, it's fundamentally flawed. The Mustang can outrun a Spitfire at low altitude, but above 15,000 feet, it becomes a sitting duck. German fighters dance around it at high altitude, while the Allison engine gasps for air like a drowning man. What Harker doesn't know is that his 30-minute test flight will lead to the most successful engine swap in aviation history. What he doesn't realize is that the simple recommendation he's about to write will transform this promising but limited fighter into the aircraft that will escort American bombers all the way to Berlin and back. The problem with the P-51 Mustang in 1942 isn't obvious to casual observers. On paper, it looks like a winner. North American Aviation designed it in just 117 days. It's faster than anything the British have at low altitude. The range is impressive, the handling is superb, and pilots love flying it. But there's a fatal flaw that renders the war Britain is actually fighting. Above 15,000 feet, the Allison engine's single-stage supercharger runs out of breath. Power drops catastrophically. Speed bleeds away. German fighters operating at 25,000 feet can attack British bombers, while the Mustang escorts struggle far below, helpless to intervene. This isn't a minor performance deficit. This is a complete mission failure. The Royal Air Force needs high-altitude escort fighters desperately. German interceptors are shredding British bombing raids because existing fighters can't climb high enough or fast enough to protect them. The Spitfire has better high-altitude performance than the Mustang, but it lacks the range for deep penetration missions. The Hurricane is obsolete. American P-47 Thunderbolts won't arrive for months. The RAF is stuck with beautiful, fast, useless Mustangs that can't fight where the war is actually happening. Ronald Harker understands this problem better than most pilots. At 33 years old, he's Rolls-Royce's chief test pilot, a man who's flown every significant British aircraft developed during the war. He's evaluated Spitfires, Hurricanes, Typhoons, and a dozen experimental designs. His job is finding the limits of aircraft performance, identifying weaknesses, and recommending improvements. When the Air Ministry asks him to evaluate the Allison-powered Mustang, Harker approaches it with the methodical precision of an engineer and the instincts of a combat pilot. The test flight begins routinely. Harker takes the Mustang through standard performance evaluations at various altitudes and power settings. Below 10,000 feet, the aircraft is magnificent. Acceleration is crisp, handling is responsive, and speed is impressive. The Mustang feels like a thoroughbred, eager and powerful, but as Harker climbs higher, the aircraft's fatal weakness becomes undeniable. At 18,000 feet, the Allison engine is struggling. At 20,000 feet, it's wheezing. At 25,000 feet, where German fighters operate with impunity, the Mustang is effectively defenseless. Harker lands after 30 minutes with a clear understanding of both the problem and the solution. The airframe is exceptional. The aerodynamics are nearly perfect. The fuel capacity is adequate for long-range missions. The only component preventing the Mustang from becoming the war's dominant fighter is the engine. Replace the Allison with a power plant capable of high-altitude performance, and this aircraft could change everything. That evening, Harker sits in his quarters at Rolls-Royce and writes the words that will alter aviation history. His recommendation is straightforward, almost casual in its phrasing, but the implications are revolutionary. The Mustang, he writes, would make a formidable fighter with a more powerful engine like the Merlin 61. He notes that preliminary calculations suggest the aircraft would be 35 miles per hour, faster than a Spitfire at equivalent power settings. The performance gains at altitude would be even more dramatic. What Harker is proposing isn't a minor modification. He's suggesting replacing the heart of the aircraft with an entirely different power plant. The Rolls-Royce Merlin 61 is a sophisticated engine with a two-stage, two-speed, intercooled supercharger designed by Stanley Hooker. It's the same engine powering the latest Spitfire variants, an engine that maintains full power well above 25,000 feet. Installing it in the Mustang would require extensive modifications to engine mounts, cooling systems, fuel lines, and control linkages. The center of gravity would shift. The propeller would need changing. The intake system would require complete redesign. Most engineers would dismiss such a proposal as impractical. The development time would be enormous. The cost would be staggering. The risk of failure would be high. But Harker's superiors at Rolls-Royce recognized the potential immediately. If the Mustang's exceptional airframe could be combined with the Merlin's high-altitude performance, the result would be unprecedented. A fighter with the range to deep escort bombers to targets in Germany and the performance to engage enemy interceptors on equal terms at any altitude. The timing of Harker's recommendation proves crucial. In May 1942, the Royal Air Force is desperately searching for solutions to the high-altitude fighter problem. Bomber losses are mounting. German interceptors are operating with near impunity above 20,000 feet. Every available fighter has significant limitations. The Spitfire lacks range. The Hurricane lacks performance. The Mustang lacks altitude capability. But the Mustang with a Merlin engine might lack nothing at all. Within days of receiving Harker's report, Rolls-Royce executives are meeting with Air Ministry officials to discuss the feasibility of the engine swap. The conversations are intense and urgent. German U-boats are strangling British supply lines. The Soviet Union is fighting for survival on the Eastern Front. American entry into the war has provided hope, but not yet results. Britain needs every possible advantage, and the Merlin-Mustang combination could provide exactly that advantage. The decision to proceed comes quickly. In August 1942, the Royal Air Force authorizes the conversion of 5 Mustang airframes to accept Merlin engines. The program receives the designation Mustang X, and the first aircraft begins modification immediately. The work is complex and demanding. Engineers must redesign the entire forward fuselage to accommodate the heavier Merlin engine. The cooling system requires complete revision. The carburetor intake moves from above the nose to below, necessitating new ductwork and structural modifications. The weight increase from the Merlin installation creates additional challenges. The 2-stage supercharged Merlin weighs over 350 pounds more than the Allison engine. This shifts the aircraft's center of gravity forward, potentially affecting stability and control characteristics. Engineers solve the problem by moving the wing slightly forward, restoring proper balance while maintaining the Mustang's excellent flying qualities. Meanwhile, parallel development begins in the United States. Major Thomas Hitchcock, the American military attaché in London, receives word of the British Mustang X program and immediately recognizes its significance. Hitchcock forwards the information to Wright Field and North American Aviation, where it generates immediate interest. The timing proves fortuitous, as negotiations are already underway with the Packard Motor Car Company for licensed production of Merlin engines in the United States. The American development proceeds with remarkable speed, and American Aviation's Performance Aircraft Base 400P 1942 before the first Merlin-powered prototyped confidence that borders on audacity. In August 51B, enormous Soleon North has even Eiffel Air Force's order zone, the Army estimates. It's a gamble on an unproven concept, but the potential, the MER rewards, justify the risk. If Aslin-Mustang combination works predicted, American bombers will finally have the long-range, high-altitude escort fighter they desperately need. The first Mustang X takes flight on October 13, 1942, with Rolls-Royce chiefed at the controls. What test pilot Ronald Harker happens during that maiden flight exceeds every prediction, every calculation, every optimistic estimate the engineers dared to make. The aircraft climbs like a rocket, accelerating through the Allison-powered version would be struggling for breath. At 22,000 feet, the Mustang X achieves 433 miles per hour, a speed that leaves observers on the ground staring in disbelief. This isn't just an improvement. This is a transformation so complete that the aircraft might as well be an entirely different machine. The same airframe that was relegated to low-altitude reconnaissance missions is now outperforming every fighter in the Royal High Altitude, where Air Force inventory. At air combat actually matters, the Mustang X is untouchable. German pilots who had learned to ignore Allison-powered Mustangs operating below their ceiling would soon face a nightmare they never anticipated. But raw speed is only part of the revolution. The real breakthrough comes when test pilots begin calculating range figures. The Merlin engine doesn't just provide more power at altitude, it delivers that power with stunning fuel efficiency. While the Allison engine gulped fuel at high power settings, the sophisticated supercharger system of the Merlin maintains performance while sipping gasoline like a touring aircraft. Initial calculations suggest the Merlin-powered Mustang could fly escort missions deep into German territory and return with fuel to spare. Across the Atlantic, American engineers are watching the British test results with growing excitement and mounting pressure. The 8th Air Force is preparing for daylight bombing campaigns that will require unprecedented fighter escort ranges. Current American fighters can barely reach the German border before turning back. The Lockheed P-38 Lightning has the altitude performance but lacks the range for deep penetration missions. The Republic P-47 Thunderbolt shows promise but won't be available in significant numbers for months. The Army Air Forces need a solution now, not next year. North American Aviation's test facility in California becomes a scene of controlled chaos as engineers race to duplicate the British modifications. The Packard-built Merlin engines arrive with their own complexities. American production techniques differ from British methods. Tooling must be redesigned. Assembly procedures require complete revision, but the potential rewards drive everyone involved to extraordinary efforts. This isn't just about building better fighters. This is about creating the weapon that could win the war. The first American Merlin-powered Mustang, designated XP-51B, lifts off from North American's test strip on November 30, 1942. Test pilot Robert Chilton advances the throttles and feels the surge of power that British pilots have been describing in their reports. The climb rate is phenomenal. At 29,800 feet, the XP-51B achieves 441 miles per hour, over 100 miles per hour faster than any Allison-powered variant could manage at that altitude. The numbers tell a story of complete aerodynamic and engineering triumph. The Merlin develops 1,390 horsepower at 23,500 feet compared to the Allison's 1,150 horsepower at 11,800 feet. This power advantage at combat altitudes translates directly into tactical superiority. German fighters that could previously attack American bombers while escort fighters struggled far below now face interceptors that can engage them on equal terms at any altitude. Production planning begins immediately. North American Aviation faces the challenge of retooling entire assembly lines while maintaining output of Allison-powered variants still needed for other roles. The company opens a second production facility in Dallas, Texas, specifically for Merlin-powered Mustangs. By early 1943, both plants are working around the clock, turning out fighters at unprecedented rates. The Inglewood facility produces P-51B models, while Dallas builds the virtually identical P-51C variant. The modifications required for Merlin installation prove extensive but manageable. The engine cowling requires complete redesign to accommodate the different cooling requirements and intake configuration. The Merlin's updraft carburetor system necessitates moving the air intake from above the propeller spinner to below it, creating the distinctive chin scoop that becomes the visual signature of Merlin-powered Mustangs. The four-bladed Hamilton standard propeller replaces the three-bladed unit used on Allison variants, providing better efficiency at high altitude. Weight and balance calculations demand careful attention. The heavier Merlin engine shifts the center of gravity forward, requiring wing repositioning to maintain proper balance. Engineers solve multiple technical challenges simultaneously while maintaining the Mustang's exceptional handling characteristics. The result is an aircraft that flies as beautifully as its predecessor while delivering performance that redefines what single-engine fighters can achieve. The fuel system modifications prove equally crucial to the aircraft's ultimate success. Internal fuel capacity increases to accommodate longer missions. The addition of an 85-gallon fuselage tank behind the pilot's seat pushes total fuel capacity to unprecedented levels for a single-engine fighter. With external drop tanks, the Mustang can carry enough fuel for missions lasting over 6 hours, a capability that transforms strategic bombing doctrine. However, these fuel capacity increases create new challenges that test pilots must master. A fully loaded Mustang with maximum fuel becomes tail-heavy and difficult to control during takeoff and initial climb. Pilots learn complex fuel management procedures, burning fuselage tank fuel first to restore proper balance, then switching to drop tanks for cruise flight, and finally using wing tanks for combat and return flight. The learning curve is steep, but the tactical advantages justify every complication. By May 1943, the first production P-51B rolls off the assembly line at Inglewood. The aircraft represents 18 months of intensive development, compressed into a timeline that would normally require 3 years. Every system has been tested, refined, and optimized. The power plant installation that began as one test pilot's casual recommendation has become a complete aircraft redesign that maintains all the original strengths while eliminating its fatal weakness. The 354th Fighter Group receives the distinction of becoming the first operational unit equipped with Merlin-powered Mustangs. Nicknamed the Pioneer Mustang Group, these pilots will test the new fighter under combat conditions that no amount of peacetime evaluation can simulate. Their mission is straightforward, but unprecedented. Escort American bombers all the way to targets deep inside Germany and engage any German fighter that attempts to interfere. What none of them realize is that they're about to demonstrate capabilities that will fundamentally alter the balance of air power over Europe. German fighter tactics have been based on the assumption that American escort fighters have limited range and altitude performance. Luftwaffe pilots wait beyond the escort fighters' operational radius, then attack bombers when their protectors turn back toward England. The Merlin-powered Mustang is about to make that entire tactical doctrine obsolete. The transformation from experimental engine swap to operational weapons system represents one of the most successful aircraft development programs in aviation history. What began with Ronald Harker's 30-minute test flight has become a fighter that will escort bombers to Berlin and beyond. The simple act of replacing one engine with another has created an aircraft that will help win the war in the air over Europe. The statistics from the first combat missions reveal numbers that stagger even the most optimistic planners. October 1943, the 354th Fighter Group's initial operations with Merlin-powered Mustangs produce results that rewrite every assumption about fighter escort effectiveness. Before the P-51B enters service, American bomber formations suffer catastrophic losses. Some missions lose 30% of attacking aircraft. Entire squadrons vanish over Germany, while their P-47 escorts turn back with empty fuel tanks, unable to protect them during the most dangerous phase of their missions. But the Mustangs change everything with brutal mathematical precision. Bomber losses plummet from 27% to 6% when P-51s provide escort all the way to the target and back. German fighter pilots who had grown accustomed to attacking undefended bombers suddenly face American interceptors at altitudes they thought were safe. The psychological impact proves as devastating as the tactical advantage. Luftwaffe pilots report seeing Mustangs over targets they considered unreachable by enemy fighters. The fuel efficiency numbers tell the real story of the revolution. Jeffrey Ethel's unpublished analysis reveals that Merlin-powered Mustangs achieve 3.3 miles per gallon, while P-47 Thunderbolts manage less than 1.8. This isn't a minor improvement in economy. This is the difference between reaching Berlin and turning back at the German border. The Merlin engine's sophisticated two-stage supercharger maintains power at altitude while consuming fuel at rates that extend operational radius beyond anything previously achieved by single-engine fighters. General Thomas Hayes captures the transformation in simple terms that mask the engineering complexity behind it. The Merlin-powered P-51 possesses the three qualities most needed to escort bombers to Berlin: range, range, and range. Everything else follows from that fundamental capability. Speed matters only if you can reach the combat zone. Firepower matters only if you can engage the enemy. Maneuverability matters only if you arrive with enough fuel to fight and return home safely. The operational deployment reveals challenges that test pilots must master through experience rather than training manuals. Captain Chuck Yeager, flying P-51s with the 357th Fighter Group, learns fuel management procedures that would intimidate airline pilots. Take off with full internal tanks plus 2 external drop tanks totaling 419 gallons of fuel. Burn the unstable rear fuselage tank first to restore proper center of gravity. Switch to external tanks for cruise flight, monitoring consumption rates constantly. Drop the external tanks when engaging enemy fighters or when they become empty. Fight on wing tank fuel, always maintaining enough reserve for the flight home across hundreds of miles of hostile territory. These procedures demand mathematical precision under combat stress. Miscalculate fuel consumption, and you face the choice between ditching in the North Sea or attempting to reach neutral territory. Burn fuel too quickly during combat maneuvering, and you lack range for the return flight. Use too little power during cruise, and you arrive late at the rendezvous point, leaving bombers undefended. Every decision carries life or death consequences multiplied across hundreds of aircraft and thousands of crew members. The German response evolves rapidly as Luftwaffe commanders recognize the threat posed by long-range American escorts. Fighter tactics that worked effectively against P-47s prove suicidal against P-51s. German pilots can no longer wait beyond escort range because the Mustangs have no practical range limit for European operations. They cannot climb above the escorts because Merlin engines maintain full power at altitudes where German fighters struggle. The fundamental advantage shifts to American forces for the first time in the daylight bombing campaign. Marshal Hermann Göring's reported reaction captures the strategic implications perfectly. When he sees Mustangs over Berlin, he knows the war is lost. German industrial cities that seemed safe from daylight attack suddenly face precision bombing protected by fighters that can engage Luftwaffe interceptors on equal terms anywhere over the Reich. The psychological impact extends beyond military considerations. German civilians witnessing American fighters over their capital city understand that their air defenses have been overwhelmed completely. The production numbers required to achieve this transformation stagger contemporary industrial observers. North American Aviation increases monthly output to 857 aircraft by expanding the Dallas facility while maintaining full production at Inglewood. Both plants operate 24 hours per day, 7 days per week. The company employs over 90,000 workers producing Mustangs, engines, components, and support equipment. Material requirements include thousands of tons of aluminum, steel, rubber, and specialized alloys processed through supply chains spanning the entire North American continent. Packard Motor Company's Merlin production faces equally demanding challenges. Each engine requires over 3,000 individual components manufactured to tolerances measured in thousandths of inches. The two-stage supercharger system alone demands precision engineering capabilities that push American manufacturing technology to its limits. Quality control procedures ensure that every engine meets performance specifications that will determine pilot survival over enemy territory. Production rates climb steadily from dozens per month to hundreds as manufacturing techniques improve and tooling becomes more sophisticated. The combat effectiveness measurements reveal transformation so complete that tactical doctrine requires complete revision. Pre-Mustang bomber escort missions typically lose 17% of escorting fighters due to fuel exhaustion, mechanical failure, or combat damage. Post-Mustang missions reduce escort losses to 3%, while achieving dramatically improved bomber protection. Fighter pilots report engaging German interceptors at distances from base that would have been impossible with previous aircraft. Individual pilot accounts provide human perspective on the technical revolution. Lieutenant Colonel John Meyer, commanding the 352nd Fighter Group, describes the difference between P-47 and P-51 operations in terms that emphasize capability rather than performance statistics. With Thunderbolts, his squadron could escort bombers partway to targets in Western Germany before fuel limitations forced them to turn back. With Mustangs, the same pilots escort bombers to targets anywhere in the Reich and return with fuel remaining for extended combat if necessary. The maintenance requirements for Merlin-powered Mustangs prove manageable despite the engine's complexity. Ground crews adapt quickly to the different servicing procedures required by the British-designed power plant. Parts availability improves as Packard production reaches full capacity and supply lines become established. Reliability statistics show Merlin engines performing as well as or better than Allison power plants, while delivering vastly superior high-altitude performance. Weather operations reveal another crucial advantage of the Merlin installation. The engine's sophisticated fuel injection system and advanced ignition timing allow reliable operation in conditions that would ground Allison-powered aircraft. Winter missions over northern Europe test every component to its limits, but Mustangs continue flying when other fighters remain on the ground. This operational availability translates directly into consistent bomber protection during the critical months when weather conditions favor defensive operations. Training programs expand rapidly to prepare pilots for the new aircraft's capabilities and limitations. Flight schools modify curricula to emphasize fuel management, high-altitude tactics, and extended-range navigation. Pilots transitioning from P-47s must learn completely different energy management techniques. The Mustang's lighter wing loading and different power characteristics require revised approach procedures for combat maneuvering. Gunnery training adapts to engagement ranges that extend far beyond previous fighter experience. The strategic bombing campaign's success rate improves dramatically once adequate numbers of P-51s reach operational status. Mission planners can finally design raids that target the most critical German industrial facilities without accepting prohibitive losses. Ball-bearing factories, aircraft plants, and synthetic fuel refineries that seem protected by distance and fighter defenses become viable targets for precision daylight attacks. The cumulative effect accelerates German industrial decline while demonstrating Allied air superiority over the Reich itself. Intelligence reports from captured German pilots reveal the Luftwaffe's growing desperation as Mustang numbers increase throughout 1944. Experienced fighter pilots describe American escorts as nearly impossible to evade due to their combination of speed, altitude performance, and unlimited range. Training programs for replacement German pilots emphasize survival techniques rather than offensive tactics. The fundamental balance of air power has shifted irreversibly toward Allied forces equipped with fighters that can engage German interceptors anywhere over occupied Europe. The logistical achievement supporting this transformation equals the technical accomplishment in complexity and scale. Fuel supplies for extended-range missions require sophisticated planning and execution. Each Mustang mission consumes over 400 gallons of high-octane aviation gasoline, multiplied across hundreds of aircraft operating from dozens of bases. Ammunition requirements increase proportionally as fighters engage enemy aircraft at greater distances from home bases. Spare parts, maintenance equipment, and specialized tools must be distributed across the entire operational theater. By late 1944, the transformation of American fighter capabilities reaches completion. Over 15,000 Mustangs have been produced, with the majority being Merlin-powered variants optimized for long-range escort missions. The aircraft that began as Ronald Harker's experimental recommendation has become the dominant Allied fighter over Europe. German air resistance collapses under sustained pressure from bomber formations protected by escorts that can engage Luftwaffe fighters anywhere over the Reich. The simple act of changing engines has altered the fundamental balance of air power and accelerated the war's conclusion. The numbers emerging from combat operations across the European theater paint a picture of transformation so complete it defies every pre-war assumption about fighter aircraft limitations. By March 1944, 8th Air Force statisticians document mission profiles that would have been considered fantasy just 18 months earlier. P-51 squadrons routinely fly 6-hour missions covering 1,200 miles, while maintaining formation discipline and combat readiness throughout the entire flight. German military analysts studying captured American aircraft and interrogating downed pilots struggled to comprehend how enemy fighters appear over targets they calculated were beyond any possible operational radius. The tactical revolution extends beyond simple range improvements. Luftwaffe commanders discover their carefully developed defensive strategies have become obsolete overnight. For 3 years, German fighter tactics relied on a fundamental assumption that American escort fighters possessed limited endurance and operational radius. Fighter wings positioned themselves beyond escort range, waited for American fighters to reach their fuel limits and turn back, then attacked undefended bomber formations during the most vulnerable phase of their missions. The Merlin-powered Mustang destroys this entire tactical framework with brutal mathematical precision. Lieutenant Colonel Francis Gabreski, leading the 61st Fighter Squadron, experiences this tactical shift firsthand during a mission to Schweinfurt in April 1944. His Mustangs encounter German fighters at distances from base that would have forced P-47s to disengage and return home. Instead, Gabreski's pilots engage the interceptors aggressively, pursue fleeing aircraft across hundreds of miles of German territory, and return to England with fuel remaining for extended combat maneuvering. The psychological impact on German pilots proves as devastating as the tactical advantage. Luftwaffe veterans report feeling hunted over their own territory by American fighters that seem to possess unlimited endurance. Weather operations reveal another crucial advantage that military planners hadn't fully anticipated. The Merlin engine's advanced fuel injection system and sophisticated ignition timing enable reliable operation in meteorological conditions that ground other aircraft types. During the brutal winter of 1943 to 1944, when icing conditions and severe weather systems sweep across northern Europe, Mustang squadrons continue flying escort missions while P-47 units remain weathered in at their bases. This operational availability translates directly into consistent bomber protection during months when German defenses should theoretically hold every advantage. Major George Preddy, commanding a flight of 352nd Fighter Group Mustangs, describes the difference in operational capability through personal experience rather than technical specifications. Before receiving P-51s, his squadron planned missions around fuel consumption calculations that dominated every tactical decision. Pilots constantly monitored fuel gauges, calculated consumption rates, and worried about reserve requirements for the return flight. With Merlin-powered aircraft, fuel becomes a tactical consideration rather than an operational limitation. Preddy's pilots engage German fighters aggressively, pursue damaged enemy aircraft until they're destroyed, and return to base with sufficient fuel for additional sorties if required. The maintenance burden associated with increased operational tempo tests ground crews to their limits, but proves manageable through systematic organization and improved supply procedures. Each Mustang requires approximately 12 man-hours of maintenance for every flight hour, but the aircraft's reliability statistics exceed expectations despite the demanding operational schedule. Engine changes become routine procedures rather than major maintenance events. Parts availability improves steadily as Packard production reaches full capacity and supply chains adapt to increased demand. Ground crews develop expertise with Merlin systems that rivals factory technicians in speed and precision. Intelligence analysis of German communications intercepts reveals the enemy's growing recognition that air superiority over the Reich has shifted permanently to Allied forces. Luftwaffe operational reports describe American fighter escorts as possessing capabilities that make traditional interception tactics ineffective. German pilots receive revised combat instructions, emphasizing survival rather than aggressive engagement. Training programs for replacement pilots focus on evasion techniques rather than offensive tactics. The fundamental assumption underlying German air defense doctrine that geography provides protection from enemy fighters has been shattered completely. Production statistics demonstrate the industrial achievement required to support this transformation. North American Aviation's combined output from Inglewood and Dallas facilities reaches nearly 900 aircraft monthly by summer 1944. Each Mustang requires over 15,000 individual components manufactured to specifications that ensure reliable operation under extreme combat conditions. Quality control procedures test every critical system before aircraft leave the factory. The production line operates with precision that rivals Swiss watchmaking, while maintaining output rates that boggle contemporary industrial observers. The strategic implications extend far beyond improved bomber escort effectiveness. German industrial planners, who had located critical manufacturing facilities beyond the presumed range of American fighters, suddenly discover their most vital production centers exposed to precision daylight attacks. Ball-bearing plants in Schweinfurt, aircraft factories in Regensburg, and synthetic fuel refineries throughout central Germany become viable targets for sustained bombing campaigns. The cumulative effect accelerates German industrial decline while demonstrating Allied air superiority over every corner of the Reich. Training modifications required for Mustang operations emphasize capabilities that previous fighters couldn't achieve. Flight schools develop curricula covering extended-range navigation techniques, high-altitude fuel management, and combat tactics at distances from base that would have been impossible with earlier aircraft. Pilots learn to think strategically rather than tactically, planning engagements that might occur hundreds of miles from friendly territory. Gunnery training adapts to longer engagement ranges and extended combat durations that test ammunition conservation skills. The human cost savings achieved through improved escort effectiveness prove as significant as the strategic advantages. Bomber crew casualty rates drop dramatically when P-51s provide protection throughout entire missions. Aircraft losses decrease from catastrophic levels to manageable percentages. Aircrew morale improves markedly when pilots and gunners know their escorts can engage enemy fighters anywhere over Europe. The psychological impact of knowing protection extends throughout the mission rather than ending at arbitrary fuel limits transforms crew confidence and mission effectiveness. German industrial intelligence efforts focus increasingly on understanding how American factories achieve production rates that seem to defy physical limitations. Captured documents reveal enemy analysts struggling to comprehend manufacturing optimistic estimates capabilities that exceed their most of American industrial potential. The ability to produce thousands of complex aircraft monthly while maintaining quality standards that ensure combat reliability represents an industrial achievement that German planners considered impossible. Ronald Harker never fired a shot in anger. He never commanded a squadron or led bombers to Berlin, but his 30-minute test flight and simple written recommendation transformed the most important fighter of World War II. One pilot's crazy idea to swap engines didn't just improve an aircraft, it changed the entire balance of air power over Europe and helped win the war itself.